The universe is hiding structures that should not exist. We will uncover 21 cosmic anomalies that defy our current laws of physics, from a star dimmed by a potential megastructure to a perfect hexagon spinning at Saturn's pole. You will gain a new perspective on reality itself by the end of this journey. What if a simple light pattern revealed a secret of alien engineering, or a ghostly circle in the void represented an entirely new class of object? How many cosmic rules are just waiting to be broken? A star over 1,000 light-years away began behaving in a way that nobody could explain. This is Tabby's star, and its bizarre flickering captured the world's attention. The Kepler Space Telescope, designed to hunt for planets, recorded its light. Instead of the regular, gentle dimming of an orbiting world, Kepler saw something wild. The star's brightness would sometimes drop by a staggering 22%. That is not a small dip. It is a colossal plunge, as if something enormous and jagged was drifting in front of it, blocking the light in a chaotic, unpredictable pattern. The woman who led the team studying this, Tabitha Boyajian, found the data so unusual that the object was nicknamed the most mysterious star in the galaxy. The immediate question was, what could possibly cause this? A planet would create a symmetrical, repeating dip. A dust cloud would behave differently. The best natural explanation proposed was a giant, fragmented swarm of comets, thousands of them passing in front of the star. But even that felt like a stretch to many, a cosmic Rube Goldberg machine of an explanation. This is when the more extraordinary idea emerged. What if we were not looking at a natural swarm, but an artificial one? The physicist Freeman Dyson once theorized that an advanced civilization would eventually need to capture all the energy from its star. They might build a vast shell or swarm of orbiting collectors around it, a structure we now call a Dyson sphere. The erratic, massive dimming of Tabby's star seemed to fit what you might expect to see from a partially built Dyson sphere, a megastructure so vast it defies comprehension. It was a hypothesis that set the scientific community ablaze, forcing a serious, if skeptical, conversation about the search for extraterrestrial intelligence. The debate raged for years, a perfect example of how science grapples with the unknown. Astronomers pointed every available instrument at the star, searching for more clues. Subsequent studies have leaned towards natural causes, suggesting vast clouds of fine dust are the real culprit. Yet, the mystery has never been entirely solved. Tabby's star stands as a monument to a profound idea, that a single, anomalous squiggle of light from a distant sun can challenge everything we think we know about what is possible, or who else might be out there building. It opened a door in our collective imagination, a door that leads directly to our next cosmic puzzle, one that is far colder and far closer to home. While the idea of a distant megastructure challenges our understanding of engineering, a single burst of sound from the cosmos questioned our very solitude. On a quiet August evening in 1977, a radio telescope known as the Big Ear was silently scanning the sky. It was a routine night at the Ohio State University, part of the long-running search for extraterrestrial intelligence. The telescope worked by listening not for complex messages but for one simple thing: a powerful, persistent radio signal at one specific frequency. And then it heard something. A volunteer named Jerry Amon was reviewing the computer printout days later, a long scroll of letters and numbers representing the faint noise of the universe. His eyes scanned across a sequence and he saw it, a string of characters so unexpected and so strong that he circled it in red pen and wrote one word beside it: wow. The WOW signal, as it became known, was a narrowband radio burst that lasted for 72 seconds. It came from the direction of the constellation Sagittarius, and it was over 1,000,000 times stronger than the background noise of space. This was not the faint crackle of a distant quasar or the random pulse of a passing satellite. Its characteristics were exactly what scientists had predicted for an artificial signal beamed across the stars. The signal rose and fell in intensity over its brief duration, precisely matching what you would expect as the Earth's rotation carried the big ear telescope's focus across a fixed point in the sky. It was a perfect candidate, yet when astronomers pointed every available dish back toward that patch of sky, they heard nothing. No repeat, no echo, just an eternal, profound silence. For decades, the search for an explanation has continued. Could it have been a comet that was not yet catalogued, reflecting sunlight in just the right way? Perhaps it was a secret military transmission, though its unique properties make that unlikely. The most captivating possibility remains that it was a one-time transmission from an advanced civilization, a cosmic hello that swept past our planet and was gone before we could even think to reply. The WOW signal endures not because we solved it, but because we could not. It is a ghost in the machine of science, a fleeting whisper that reminds us how vast the cosmic ocean is and how small our net remains. It is a mystery written in the air, but our next anomaly is one you could almost reach out and touch, a perfect geometric shape spinning in the deep freeze of our own solar system. Deep within the frigid silence of our solar system, a visitor from another star quietly slipped past the sun. In October 2017, astronomers in Hawaii spotted an object moving at incredible speed, an object that did not belong to us. They named it Oumuamua, a Hawaiian word for scout. It was the first confirmed traveler from interstellar space, and its brief visit turned everything we thought we knew about cosmic debris on its head. This was no ordinary comet or asteroid. For starters, its shape was profoundly strange. Based on the way its brightness changed as it tumbled, scientists deduced it was highly elongated, perhaps 10 times longer than it was wide. Imagine a cosmic cigar or a pancake tumbling through the void, a shape unlike any natural object we have ever seen in our own solar system. Then came the true mystery, its acceleration. As Oumuamua raced away from the sun, it sped up slightly. A comet does this when ices on its surface heat up and vent gas, forming a visible tail. Yet Oumuamua had no tail, no coma, no cloud of gas or dust around it whatsoever. It was a completely dark, inert object, but something was giving it an extra push. This non-gravitational acceleration defied easy explanation. The scientific community scrambled. Mainstream astronomy proposed fascinating natural theories. Perhaps it was a shard of a Pluto-like world, a nitrogen ice fragment blasted from its home system. Maybe it was a hydrogen iceberg, a fragile object that outgassed hydrogen so pure it was invisible to our telescopes. These were creative solutions, but each came with its own set of problems, requiring just the right conditions to exist. This opened the door for a more radical idea, championed by Harvard astronomer Avi Loeb. He proposed that Oumuamua's strange acceleration and unusual shape were consistent with a light sail, a form of propulsion used by theoretical spacecraft. A thin, reflective sheet could be pushed by the radiation pressure from stars, explaining its speed boost without any visible exhaust. Could this strange, tumbling object be a piece of ancient alien technology, a derelict probe from a civilization long gone? The debate it sparked was fierce, a clash between the disciplined search for natural causes and the audacious consideration of the artificial. Oumuamua is now long gone, a faint speck vanishing into the black. Its fleeting passage left us with no clear answers, only a profound unease. It challenged our most basic assumptions, forcing us to ask if the universe is filled not just with rocks and ice, but with the artifacts of other builders. And as if to prove the point, the cosmos soon sent us another visitor, one that was even more bizarre. The discovery of Oumuamua hinted at design on a small scale, but the cosmos can produce structures of such immense proportions they seem to rewrite the rules of reality itself. Buried within the faint light of ancient quasars, astronomers found something that should not be, a formation so colossal it defies our most fundamental assumptions about the universe. They call it the Giant Arc, a near-symmetrical curve of galaxies spanning an almost incomprehensible 3.3 billion light-years. To grasp that scale, picture a single light-year, the distance light travels in a full year. Now multiply that by 3,300,000,000. This arc is not a physical object you could touch, but a gravitational fingerprint, a pattern in the distribution of matter that forms a distinct crescent-shaped structure across the sky. Its existence directly confronts a cornerstone of modern cosmology, the cosmological principle. This principle states that on a very large scale, the universe should look roughly the same everywhere, a homogeneous and isotropic soup of matter. There is a theoretical limit to how big any single structure should be able to grow before the smoothing effect of cosmic expansion tears it apart. The giant arc is not just big, it is 3 times larger than that theoretical limit. It should not exist, and yet the data says it does. This was not found by looking at the galaxies themselves, but by analyzing the light from even more distant quasars, the brilliant cores of active galaxies. As this light travels for billions of years to reach us, it passes through clouds of matter, like the one forming the giant arc. These clouds imprint a specific signature on the light, allowing scientists to map the invisible architecture of the cosmos. The arc is a ghostly silhouette, a pattern revealed only by its shadow. Its discovery forces a profound question. Is the cosmological principle, a foundation for so much of our physics, simply wrong? Or are we seeing the effects of physical processes we do not yet understand, forces that can sculpt the universe on scales we once thought were impossible? The giant arc is a crack in the foundation of our cosmic model, a suggestion that the largest structures in existence might be organized in ways we are only beginning to perceive. If the universe's grandest architecture is not random, what other impossible designs are waiting to be found, perhaps even closer to home? While the giant arc reveals patterns in the grandest scales of matter, other mysteries appear as perfect, ghostly circles etched onto the sky. These are the odd radio circles, or ORC, and they are unlike anything else we have ever seen. Discovered only a few years ago by the powerful ASCAP radio telescope array in Australia, these objects are colossal rings of radio wave emission, so vast that each one could easily swallow an entire galaxy. The most baffling part, they are completely invisible in every other type of light. Point an optical, infrared, or X-ray telescope at their location, and you will see nothing but empty space. They are phantoms detectable only by their faint radio whisper. One of the leading natural explanations suggests these circles could be the immense, spherical shockwave from a cataclysmic event. Picture a merger of 2 supermassive black holes, an event of such staggering power that it sends a tsunami of energy roaring through intergalactic space. This wave would accelerate electrons to near light speed, causing them to spiral around magnetic fields and glow in radio waves, creating a perfect, expanding sphere that we see as a ring from our perspective. Another theory posits they are the aftermath of a starburst galaxy, a period of frantic star formation that ends with a galactic wind so powerful it blows a colossal bubble into the surrounding gas. Yet, both of these ideas struggle to explain the sheer number and perfect circularity of the ORCs. Their ghostly perfection leads some to wonder if we are seeing something even more exotic, perhaps the imprint of a wormhole or the remnant of a collision between universes in the multiverse, though these remain highly speculative. What is undeniable is the collaborative, global effort to understand them. Astronomers across the world are now coordinating, using telescopes like the South African Meerkat to peer deeper into these rings, mapping their intricate structures in the hope of finding a clue. The ORCs represent a brand new class of astronomical object, a reminder that our map of the cosmos is still filled with blank spaces marked "Here be dragons." They are cosmic Rorschach tests, challenging us to decide if we are looking at a known phenomenon pushed to an extreme, or the first glimpse of a physical process we have not yet dreamed of. And just as we grapple with these faint circles in the void, another impossible shape was found much closer to home, a perfect hexagon spinning at the pole of a giant planet. At the North Pole of Saturn, a perfect geometric storm rages. This is no ordinary swirl of clouds, but a colossal, six-sided jet stream, a hexagon large enough to fit 4 Earths inside its boundaries. It was first glimpsed by the Voyager probes in the 1980s, and when the Cassini spacecraft arrived decades later, it was still there, unchanged and defiantly geometric. In the turbulent, fluid atmosphere of a gas giant where storms blend and fade, this hexagon has persisted for at least 40 years, a permanent puzzle etched into the clouds. How does a perfect hexagon form and endure in a place of such chaos? The answer seems to lie in the complex physics of spinning fluids. Scientists have recreated miniature versions of this phenomenon in laboratories. By placing a cylinder of water on a spinning table, they can simulate the different wind speeds and layers of a planetary atmosphere. When the rotation is just right, stable, polygonal shapes emerge within the swirling fluid. This suggests Saturn's hexagon is a type of standing wave, a stable pattern carved into the fast-moving jet stream that acts like a barrier, containing the chaotic weather within its 6 stark walls. It is a natural, albeit stunning, atmospheric phenomenon, yet its perfection is so jarring it feels designed, as if an unseen geometer drew a line around Saturn's pole. This structure shows us that the laws of physics can produce shapes of startling precision, even in the most violent environments. It forces us to reconsider what is natural. If a simple hexagon at our cosmic doorstep can captivate and confuse us for decades, what does that say about the more distant geometric anomalies we are only beginning to find? Saturn's hexagon is a masterpiece of natural physics, but another structure, this one at the very edge of our own solar system, is a masterpiece of cosmic confusion. Far beyond the orbit of Pluto, where the Sun's influence wanes and interstellar space begins, a NASA spacecraft called IBEX made a startling discovery. It was designed to map the boundary of our solar system, a protective bubble known as the heliosphere. But instead of a smooth, predictable frontier, IBEX found a ribbon. This is not a ribbon of light or color you could see with your eyes. It is a vast, intense band of energetic neutral atoms, a river of particles 2 to 3 times brighter than anything else in the sky, and it curves across the sky in a shape that should be impossible. According to every standard model of the heliosphere, this ribbon simply should not be there. The boundary was supposed to be a more chaotic and diffuse zone, not dominated by a single, crisp, and incredibly long structure. The mystery only deepens when you learn its orientation. This immense ribbon appears to be perfectly aligned with the direction of the galactic magnetic field that permeates our local region of the Milky Way. It is as if a giant cosmic finger is pointing directly at our solar system, leaving a mark on its outer shell. So what could possibly create such a perfect and unexpected signature? One leading theory suggests it is a reflection. As the solar wind, that constant stream of particles from the sun, flows outward and meets the interstellar medium, some particles are thought to be reflected back inward. The galactic magnetic field might be acting like a mirror, focusing these returning particles into the intense, ribbon-like band that IBEX observed. Another idea posits that the ribbon is a direct imprint of the interstellar medium itself, a region where the flow of particles from the galaxy is slowed and diverted by our solar bubble, creating a shockwave that glows with energetic atoms. For over a decade, scientists have been trying to solve this puzzle, creating ever more complex computer models to replicate the ribbon's existence. Yet a fully satisfying explanation remains elusive. The IBEX ribbon is a humbling reminder that we do not even fully understand the walls of our own cosmic home. It is a structure painted on the outermost fence of our solar system, a cryptic message written in particles that challenges our grasp of the local universe. If our own backyard holds such profound mysteries, what impossible architecture must lie in the deep fields between the galaxies? The sheer scale of the IBEX ribbon feels staggering, yet it is dwarfed by structures that make our entire solar system seem like a speck of dust. Far beyond our local galactic neighborhood, astronomers have mapped a formation so immense it redefines the word colossal. This is the Sloan Great Wall, a filament of galaxies stretching for 1.4 billion light-years. It is not a solid wall, of course, but a vast, river-like concentration of galaxies, a backbone of the cosmic web that forms the largest known structure in the entire universe. Its discovery came from one of the most ambitious maps of the cosmos ever made, the Sloan Digital Sky Survey. By meticulously measuring the redshift of millions of galaxies, which tells us how fast they are moving away from us, astronomers could plot their positions in 3 dimensions. When they did, this immense wall emerged from the data, a cosmic continent surrounded by vast, empty voids. Its existence creates a profound tension with one of cosmology's most cherished ideas, the cosmological principle. This principle states that if you look at the universe on a large enough scale, it should appear smooth and uniform like a well-mixed batter. There should not be lumps the size of the Sloan Great Wall. The statistics are what truly boggle the mind. The probability of such a vast structure forming by random chance in a homogeneous universe is incredibly low. It forces a difficult question upon us. Is the cosmological principle simply an approximation, a useful idea that breaks down at these grandest of scales? Or does the existence of the Great Wall point to something fundamental we are missing in our models of dark matter and cosmic evolution? Perhaps the mysterious dark matter, which makes up most of the universe's mass, clumps together in ways we do not yet understand, sculpting these titan filaments through gravitational forces we are only beginning to map. Confronting the Sloan Great Wall means pushing cosmology to its limits, questioning the very framework we use to describe reality. And just as this structure challenges our ideas of cosmic order, the next anomaly challenges our most basic definition of what a star can even be. Some stars are running for their lives. They are the hypervelocity stars, cosmic projectiles flung through the galaxy at speeds so immense they can achieve the impossible, escaping the gravitational clutches of the Milky Way itself. The first of these renegades was discovered in 2005, a sun streaking away from the galactic center at over 2 million miles per hour. To be flung from our galaxy, a star needs to be traveling at what is known as escape velocity, a speed so great that the pull of billions of suns cannot hold it back. These stars have achieved that, becoming unbound travelers on a one-way trip into the intergalactic void. The immediate question is, what cosmic cannon could possibly launch a star with such force? The prime suspect sits at the very heart of our galaxy, the supermassive black hole known as Sagittarius A star. The leading theory involves a tragic dance between three bodies. Imagine a binary star system, two stars orbiting each other, venturing too close to the black hole's immense gravity. The black hole's pull can tear the binary apart, capturing one star into a tight orbit while violently flinging the other away at a tremendous speed like a slingshot. This three-body interaction is one of the few natural events powerful enough to explain these stellar escapees. We have even tracked some of these stars, like the one designated He 0437-5439, on trajectories that trace directly back to the galactic center, a virtual fingerprint pointing to the black hole as the culprit. Yet, as with all cosmic mysteries, the story may not be so simple. Not every hypervelocity star has a trajectory that leads back to the galactic core. This opens a tantalizing, speculative door. Could some of these interstellar travelers have a different, even more incredible origin? What if a star moving at impossible speeds is not a natural projectile, but an artifact? Could an advanced civilization, having mastered stellar engineering, use a star as a propulsion system for a generation's ship on an epic voyage between galaxies? Or perhaps these outlying stars are not the engines themselves, but ancient navigation beacons, left over from a time when the galaxy was charted by forces we can scarcely comprehend. While the natural explanation is the most probable for the majority, the existence of any outlier challenges us to wonder if we are seeing the handiwork of nature alone or something else entirely. These runaway stars force us to look up at the night sky not as a static painting, but as a dynamic highway, filled with travelers on journeys that began with a cataclysm, or perhaps with a purpose. And if stars can be flung across the cosmos, what other impossible objects might be sailing through the darkness, not as natural formations, but as deliberate constructions? The universe has a way of sending signals that seem to whisper of intelligence, only to reveal a deeper, more violent truth. In 1967, a young graduate student named Jocelyn Bell Burnell was reviewing data from a radio telescope she had helped build, a sprawling network of wires and poles covering 4.5 acres of English countryside. She noticed a curious, persistent signal, a series of sharp, rhythmic pulses arriving every 1.337 seconds with a precision that was absolutely unerring. It was so regular, so perfectly timed that it defied any known natural explanation. The signal was dubbed LGM-1, with LGM standing for Little Green Men. The team, led by her supervisor Anthony Hewish, had to seriously consider the breathtaking possibility that they were listening to a beacon, an interstellar lighthouse built and operated by an advanced civilization. The pulses were that perfect. The discovery sent a ripple of profound excitement and unease through the small team. Here was a signal that fit the predicted profile of an artificial transmission, a cosmic metronome ticking away in the void. The mystery lasted for months, a period of intense scrutiny and secretive discussion. The answer, when it finally came, was not from Little Green Men, but from one of the most extreme objects in the universe. They had discovered a pulsar, a rapidly spinning neutron star. A neutron star is the unimaginably dense corpse of a massive star that has gone supernova, a sun compressed into a sphere just a dozen miles across. A single teaspoon of its material would weigh billions of tons. As this stellar cinder spins, its powerful magnetic field beams radiation out from its poles like a cosmic lighthouse. If that beam sweeps across Earth, we see it as a pulse with every rotation. The perfect timing was not a sign of intelligence, but a consequence of the incredible stability and ferocious rotational speed of a stellar remnant. Jocelyn Bell Burnell and Anthony Hewish had uncovered a new class of astronomical object, a discovery for which Hewish would later receive a Nobel Prize, though Bell Burnell's crucial role was famously overlooked. The story of LGM-1 is a foundational parable in the search for cosmic company. It teaches a vital lesson about the discipline of science, demonstrating the importance of seeking natural explanations first, no matter how tantalizing the alternative may be. Yet it also highlights the thin, shimmering line we walk, where the utterly natural can so perfectly mimic the artificial. This cautionary tale of a cosmic metronome prepares us for our next anomaly, where the rhythm is not in radio waves, but in the very fabric of spacetime itself, a steady drumbeat from colliding black holes. The allure of a distant megastructure began to fade under the harsh light of new data. Years of intense observation of Tabby's star, that celestial enigma, finally yielded a crucial clue, not in the star's brightness but in its color. When the star dimmed during its mysterious dips, astronomers meticulously analyzed the light that managed to filter through. They discovered that blue light was blocked more effectively than red light. This is the telltale signature of dust. A solid object like a planet or a rigid megastructure would block all wavelengths of light equally, creating a uniform dimming. The fact that the starlight was reddened pointed decisively to a cloud of fine particles, each one smaller than a grain of sand, scattering the shorter blue wavelengths. The dream of a Dyson sphere crumbled, replaced by a more mundane yet deeply perplexing reality. The dimming was caused by dust, but this resolution only opened a new and equally baffling mystery. What kind of dust behaves like this? The dust clouds around young stars are typically symmetric and orbit in a predictable disk. The dust around Tabby's star is chaotic, uneven, and clumpy, creating those bizarre, jagged dips in light. Its composition is also strange, not behaving like the common silicate dust found in our own solar system. The origin of this immense, swirling shroud of fine material remains an active puzzle. Could it be the aftermath of a catastrophic planetary collision, a cloud of debris so vast it periodically eclipses its parent sun? Or is it a huge swarm of cold comets, far larger than any in our system, breaking apart and spreading their dusty innards across the star's face? The journey of KIC 8462852 is a masterclass in the scientific process. It began with a breathtaking anomaly that sparked our most profound hopes and fears. The initial, extraordinary hypothesis of alien engineering served a vital purpose. It galvanized global attention and directed a flood of telescopes toward the star, accelerating its study. But science, with its patient and self-correcting nature, followed the evidence wherever it led, even if that path was away from the sensational and toward the complex. This case teaches us that the universe is under no obligation to be simple or to conform to our narratives. The truth is often layered, a problem of astrophysics that is, in its own way, just as captivating as fiction. We traded a singular, epic answer for a richer, more intricate question, a reminder that grounding a mystery does not make it any less wondrous. And as we will see, some cosmic signals refuse to be grounded at all, presenting a rhythm so perfect it seems to defy natural explanation. Our own galaxy is not adrift in a random sea. It appears to be caught in a current, a mysterious and controversial stream pulling thousands of galaxy clusters in a single, specific direction. This phenomenon is called the dark flow, and if real, it points to something immense and unseen beyond the edge of everything we can observe. The discovery came from analyzing the cosmic microwave background, the afterglow of the Big Bang itself. Scientists studied this relic radiation as it passed through enormous clusters of galaxies. As the light interacts with hot gas in these clusters, it gains a tiny bit of energy, a subtle shift known as the kinematic Sunyaev-Zeldovich effect. By meticulously measuring this shift, researchers could detect the velocity of these galaxy clusters. What they found was staggering. These clusters, scattered across billions of light-years, were all moving in a coordinated bulk flow toward a single point in the sky, a motion separate from the universe's overall expansion. This was not just a gentle drift, it was a river of galaxies flowing with a purpose. The sheer scale of this motion is what defies explanation. The gravitational pull of all the known matter in the observable universe should not be strong enough or organized enough to create such a coherent flow on such a vast scale. So what is pulling them? The most radical and thrilling hypothesis is that the dark flow is the gravitational tug of something entirely outside our observable universe. A colossal concentration of matter, another universe in a vast multiverse, could be exerting an influence from beyond the cosmic horizon, a place we can never see. It is a ghostly hand reaching from the void, yet the scientific community remains deeply divided. Skeptics argue this could be an artifact of incomplete data or systematic errors in the complex measurements. Perhaps our map of the cosmic microwave background is not yet precise enough, and we are seeing patterns in the noise. The debate rages because the stakes are cosmically high. Confirming the dark flow would mean our universe is not an isolated island, but one of many, and that we can feel the gravity of our cosmic neighbors. It would shatter the principle that the observable universe is all there is to see. This anomaly challenges the final frontier, the very boundary of the knowable, suggesting that what lies beyond is not just emptiness but structure. And if the universe itself can be pulled by unseen giants, then perhaps the end of a single star can also defy our expectations in ways just as profound. Sometimes the most persistent mysteries are born not from what is out there, but from our own desire to see it. Orbiting our planet is a legend, a story of an ancient alien satellite known as the Black Knight. For decades, tales have circulated of a 12,000-year-old object of unknown origin, silently circling the Earth, a watchful sentinel from a distant world. The truth, however, is a fascinating lesson in how myth can be cobbled together from the mundane fragments of our own exploration. The legend began to coalesce in the 1960s, but its roots are a patchwork of separate events. In 1928, radio amateurs in Norway began picking up strange, delayed echoes of their own transmissions, a phenomenon that sparked early speculation about an object in space reflecting the signals. Decades later, in the early days of the space race, unusual objects were seen on radar and reported by astronauts. The most famous of these was a dark, tumbling object spotted during a Gemini mission, which was later identified as a thermal blanket lost during a spacewalk. Each of these separate, explainable incidents was a single piece of a puzzle, but they were pieces from entirely different boxes. Conspiracy theorists and popular culture wove them together into a single, coherent narrative, that of the Black Knight satellite. The story was compelling, a perfect blend of mystery and hidden history. It was given a dramatic name and an ancient pedigree, capturing the public imagination in books and documentaries. Yet, every time astronomers have looked for this specific object with modern tools, they have found a perfect match for a known piece of space debris, often a piece of insulation or a panel from a modern satellite. The Black Knight is a phantom, a composite ghost assembled from our own technological litter and our innate longing for cosmic company. It serves as a powerful case study in how the human mind abhors a vacuum of information, instinctively filling the void with stories that resonate with our hopes and fears. We see a strange light, an unexplained radar blip, and the narrative engine begins to turn, constructing a reality far more thrilling than the simple truth of a lost piece of equipment. This myth demonstrates that the most compelling structures in space are sometimes the ones we build in our own minds, narratives that orbit our planet just as surely as any satellite. Yet this very human tendency to seek patterns makes the next anomaly so deeply unsettling, because it presents a pattern that is undeniably, mathematically real. A signal from deep space does not just repeat, it chatters. Unlike the singular, dramatic pulse of the WOW signal, a source known as FRB 121102 sends out its powerful, millisecond-long radio bursts again and again. It is a cosmic chatterbox broadcasting from a dwarf galaxy an almost unimaginable 3 billion light-years away. These fast radio bursts, or FRB, pack more energy in a single flash than our sun emits in 80 years, and then, for some repeating sources, they do it over and over. The mystery is not just their power, but their source. What natural engine could possibly produce such intense, fleeting, and repeating explosions? The leading suspect is a magnetar, a type of neutron star with a magnetic field so powerful it could erase a credit card from half the moon's distance away. Theorists suggest that starquakes on the surface of these supermagnetic corpses could release titanic shudders of energy, blasting out the radio waves we detect. Another possibility involves a neutron star in a tight orbit with another massive object, perhaps a black hole. As they spiral inward, the immense tidal forces could rip material from the star's surface, creating violent, repeating outbursts. But the repeating nature of FRB 121102 makes other cataclysmic events, like a one-time neutron star merger, impossible. This is not a final death cry, but an ongoing, volatile process. The speculative and far more tantalizing idea is that we are listening to something engineered. Could these incredibly bright, focused, and repeating pulses be the leakage from an interstellar communication system, a lighthouse for galactic navigation, or even the power beams of starships traveling at immense speeds? The energy requirements are staggering, but not entirely beyond the realm of a hypothetical Type 2 civilization. The key to narrowing these possibilities came from a technological leap. For years, FRBs were just fleeting blips, impossible to locate with any precision. Then, telescopes like the Canadian CHIME and the Australian Square Kilometre Array Pathfinder achieved something remarkable. By using multiple dishes spread across vast distances, they could triangulate the signals with incredible accuracy, pinpointing FRB 121102 to its specific host galaxy. This was a watershed moment. It proved these bursts were not local interference, but true extragalactic events, allowing scientists to study the environment that spawns them. That environment itself is a clue, a small, unassuming dwarf galaxy that seems to be a prolific factory for these strange signals. Fast radio bursts represent one of the most dynamic and puzzling frontiers in modern astronomy, a field where new discoveries are made almost monthly. They force us to confront the limits of our knowledge about the most extreme objects in the universe, reminding us that the cosmos is filled with brief, brilliant screams of energy whose echoes we are only just beginning to catch. And sometimes the most profound cosmic messages are not in the repeating signals, but in the silent, empty patches of sky where nothing should be, yet something is. Deep within the heart of our own galaxy, a mysterious fog of energy clings to the darkness. This is the galactic center excess, a diffuse and unexplained glow of gamma rays emanating from the core of the Milky Way. It is not the brilliant light of stars or the fierce glare of the central supermassive black hole, but something far more subtle and pervasive, a faint shimmer detected by the Fermi Gamma Ray Space Telescope. This orbiting observatory has mapped the sky in high-energy light, and the data revealed something peculiar, a surplus of gamma rays billowing from the galactic center that our standard models of astrophysics could not account for. The heart of our home is radiating an energy that we do not fully understand. So what is causing this persistent, ethereal glow? The scientific debate revolves around two compelling and profoundly different possibilities. The first and most exotic theory points to dark matter. We know this mysterious substance exists because of its gravitational pull on galaxies, but we have never directly observed what it is made of. One leading idea suggests dark matter could be made of theoretical particles called WIMP, or weakly interacting massive particles. If these particles were to collide and annihilate each other, they would produce, among other things, gamma rays. The distribution and energy of the galactic center excess fit remarkably well with what some models predict for the annihilation of dark matter. It is a tantalizing prospect, the idea that we are seeing the indirect signature of the universe's most elusive substance, a ghostly signal from the shadows of reality. The other, more conventional explanation points not to new physics, but to a hidden population of ancient stellar corpses. The galactic center is a densely packed stellar metropolis, and it could be teeming with thousands of pulsars, the spinning neutron stars we encountered earlier. These cosmic lighthouses emit powerful beams of radiation, including gamma rays. A vast collection of them, each too faint to be seen individually, could collectively produce the exact diffuse glow that Fermi observes. This is the astrophysicist's Occam's razor, a solution that relies on known objects, even if they are in an unprecedented and unseen multitude. The challenge for scientists is to disentangle these two narratives. Are we looking at the first indirect evidence of dark matter, a discovery that would revolutionize particle physics and cosmology? Or are we simply seeing the accumulated light from a celestial graveyard, a testament to the frenzied star formation that once dominated the galactic core? The significance is monumental. Confirming the dark matter hypothesis would be one of the greatest scientific breakthroughs of the century, finally giving a face to the invisible 85% of the universe's matter. But the pulsar explanation is equally compelling, forcing us to rethink the violent history and crowded architecture of our galaxy's central region. This excess is a humbling reminder that some of our most profound cosmic puzzles are not found in the distant voids, but right here in our own backyard, a persistent whisper from the center of everything we call home. And if the heart of our galaxy holds such a deep secret, what impossible structures must lie in the vast, empty spaces between the clusters of galaxies themselves? Even the Sloan Great Wall seems almost local when compared to the true champion of cosmic scale. The Hercules-Corona Borealis Great Wall is a structure so vast it strains the very definition of the word, a sprawling supercluster of galaxies stretching for an almost incomprehensible 10 billion light-years. To hold that distance in your mind, consider this: the entire observable universe is only about 93 billion light-years across. This single structure, this filament of galactic clusters, accounts for more than a tenth of the known cosmos. Its discovery did not come from a telescope capturing a pretty picture, but from a clever and indirect mapping technique using the most violent explosions in the universe. Astronomers used the fleeting, brilliant flashes of gamma-ray bursts as cosmic lighthouses. These bursts mark the locations of massive stars in distant galaxies. By plotting the positions of thousands of these bursts in 3 dimensions, a pattern emerged in the data, a staggering concentration, a wall of matter on a scale that was previously unimaginable. The existence of such a behemoth sends shockwaves through the foundations of cosmology. It stands in direct opposition to the cosmological principle, the idea that the universe should be smooth and uniform when viewed on a large enough scale. The Hercules-Corona Borealis Great Wall is the ultimate lump in the cosmic batter, a structure so massive that it should not have had enough time since the Big Bang to form under the influence of gravity alone. So what are we seeing? Is this a statistical fluke, a chance alignment that only appears to be a connected structure from our particular vantage point in the cosmos? Or is it a glaring sign that our understanding of the universe's infancy, of dark energy, or of gravity itself, is fundamentally incomplete? Perhaps the seeds for these gargantuan structures were planted in the first moments of creation, with quantum fluctuations in the primordial universe inflated to sizes we are only now beginning to measure. Confronting this wall means questioning the limits of what we can observe. Is it even possible to see the true edges of such an entity, or are we merely tracing its shadow? This discovery forces a profound shift in perspective, suggesting that the grand tapestry of the cosmos might be woven with threads far thicker and longer than we ever dreamed. And if the distribution of galaxies can be so uneven, it makes you wonder what other assumptions are ripe for challenge, like the perfect uniformity of the universe's oldest light. That ancient light from the Big Bang holds a ghostly fingerprint, a cold spot in the cosmic microwave background that simply refuses to be explained. This is not a tiny blemish, but a colossal region of space, a vast and chilling patch in the universe's first light where the temperature dips mysteriously lower than the surrounding warmth. Imagine the entire cosmos as a warm, glowing surface, and then one area, large enough to contain thousands of galaxies, feels inexplicably colder. This is the CMB cold spot, a relic from the universe's infancy that challenges our most fundamental models. The European Space Agency's Planck satellite, our most detailed mapmaker of this primordial light, confirmed its existence beyond any doubt. It is not an instrument error or a statistical fluke. It is a real feature imprinted on the sky. So what could create such a profound cold spot in the afterglow of creation? The most straightforward explanation astronomers proposed was a supervoid, an immense and mostly empty region of space spanning billions of light years. If such a void existed between us and the cold spot, the cosmic microwave background photons passing through it would lose energy as they climbed out of its gravitational well, a process known as the integrated Sachs-Wolf effect. This would make the light from that direction appear colder, just as we observe. It is an elegant solution, but there is a problem, a massive one. Astronomers have searched for this hypothetical supervoid, and while they have found some underdense regions in that part of the sky, none are nearly large enough or empty enough to account for the extreme cold we see. The numbers do not add up. The proposed void is not void enough. This failure of the simplest explanation has opened the door to far more exotic possibilities. One theory suggests the cold spot could be a cosmic texture, a flaw in the very fabric of space-time dating back to the universe's rapid expansion after the Big Bang. Think of the early cosmos cooling and settling like water freezing into ice. Sometimes the transition is not perfectly smooth, creating cracks and defects. A cosmic texture would be such a defect, a knot in space-time whose gravitational influence could leave a cold imprint on the CMB. The most staggering hypothesis, however, is that this cold spot is evidence of a collision with another universe. In the multiverse theory, our universe is one bubble in a vast cosmic foam, constantly inflating and sometimes brushing against other bubbles. A collision with a neighboring universe in the distant past could have drained energy from that region of our cosmos, leaving behind this permanent cold scar as a testament to the contact. It is a breathtaking idea that we might have tangible evidence for a cosmos beyond our own, written in the faint chill of the Big Bang's fading heat. The CMB cold spot remains one of cosmology's most profound puzzles, a place where our standard model of the universe frays at the edges, hinting at physics and realities we can only begin to imagine. This relic from the beginning of everything challenges the smooth story we tell about our origins, and just as it questions the universe's infancy, our next anomaly challenges the very process of building planets. The hunt for alien megastructures did not end with the fading light of Tabby's star. It simply evolved, moving from the haunting dips of a single star to a systematic, galaxy-wide census. This search now scans the cosmos for a specific kind of waste heat. The logic is beautifully simple. If an advanced civilization were building a Dyson sphere, a vast swarm of energy collectors around its star that captured stellar energy has to go somewhere. The laws of thermodynamics are unbreakable. The energy would be used and then re-radiated back into space as lower energy infrared light. So astronomers are not just looking for something blocking a star, they are looking for a star that seems too cold for its size, yet is inexplicably glowing with infrared warmth. It is the cosmic equivalent of finding a house with all its lights off on a cold night, but whose walls are radiating a peculiar and unexpected heat. Major infrared sky surveys, like the one conducted by the Wide Field Infrared Survey Explorer, or WISE telescope, have scanned millions of stars for this exact signature. And they have found candidates. Stars like TYC 6111 1162-1 were flagged for their strange infrared excess, a profile that made them stand out from the crowd. The initial excitement is always palpable, a spark of possibility. Yet this is where the rigorous process of science takes over. Follow-up observations with more powerful instruments almost always find a natural culprit. In nearly every case so far, the excess infrared light is traced back to a circumstellar disk, a vast ring of warm dust and debris orbiting the star, much like the Kuiper belt in our own solar system, but on a far grander scale. These are the birthplaces of planets, or the graveyards of planetary collisions, not the glittering surfaces of alien power plants. This repeated cycle of discovery and natural explanation is not a failure of the search. It is its very essence. Each candidate that is ruled out refines our methods and sharpens our focus. We are learning what a true megastructure signature would not look like, which is a crucial step toward recognizing what it might. The absence of evidence is not evidence of absence. It is a process of elimination, a meticulous narrowing of the cosmic haystack. This disciplined approach shows how science tackles its grandest questions, not with a triumphant leap, but with the patient, persistent turn of a dial, filtering out the noise of the natural world in the hope of one day finding a signal that refuses to be explained away. We apply this same rigorous skepticism to our next potential artifact, a discovery that suggests the very first stars in the universe may have left behind fossils of impossible size. The search for intelligence has always been focused on the distant and the ephemeral, on signals and structures light years away. But what if the evidence is already here, hiding in plain sight? The concept of a Bracewell probe offers a chillingly plausible alternative. Proposed by the scientist Ronald Bracewell in the 1960s, this is the idea of an autonomous robotic scout sent by an advanced civilization to quietly monitor a promising planet like our own. Rather than communicating across the vast interstellar gulf, such a probe would simply park itself in our solar system and wait, observing our development for centuries or millennia, transmitting its findings home only when we reached a stage worth reporting. It is a cosmic surveillance device, and it would be designed not to be noticed. This is where the hypothesis becomes truly fascinating and deeply challenging. How would we ever find such an object? A Bracewell probe would almost certainly be camouflaged. It might mimic a common asteroid or a dormant comet. its artificial surface weathered to look like ancient rock and ice, its shape carefully chosen to appear natural to our telescopes. It would not broadcast its presence but simply drift in a stable orbit, a sleeper agent in the cosmic dark. So what tiny flaws in its disguise might give it away? Scientists have theorized about potential signatures of an artificial probe. Its composition might be unusual, made of materials not found in natural asteroids, like refined metals or alloys, impurities that do not occur in nature. Its trajectory could be a telltale sign, a path through the solar system that is too perfect, too energy efficient, or one that brings it repeatedly past Earth in a way that seems more like a reconnaissance loop than a random orbit. We might detect a faint, unnatural emission of heat or radio waves from its surface, the waste heat of its internal systems, or a periodic, low-power signal beamed toward its home star. The fundamental difficulty is one of scale and expectation. Our solar system is filled with millions of asteroids and cometary nuclei. We have only examined a tiny fraction of them in any detail. To find a single artificial object among that sea of natural debris would be like finding one specific, cleverly painted grain of sand on an entire beach. It requires a shift in our entire approach, from scanning the heavens to scrutinizing the rocks in our own backyard with a new, suspicious eye. The implications of actually discovering one are staggering. It would be the single most important artifact in human history, proof that we are not only not alone, but that we have been watched. The protocols for such a discovery are murky at best. There is no agreed-upon global procedure, no cosmic prime directive to guide us. Would we attempt to communicate with it? Would we try to retrieve it, risking the activation of some unknown defense mechanism? Or would we simply observe it from a distance, forever wondering if it was observing us back? This idea transforms the search for extraterrestrial intelligence from an abstract listening exercise into a tangible hunt for a physical artifact, a piece of someone else's technology that might be lurking just beyond the orbit of Mars. It suggests that the ultimate message from the stars might not be a radio signal, but a silent, patient visitor, one that has been waiting for us to grow up enough to finally see it. And this notion of a hidden, ancient presence leads us directly to a final object whose origins are so mysterious. They too hint at a story we have not yet been told. A dying star has painted a perfect red rectangle in the sky. Known as the Red Rectangle Nebula, this cosmic artwork lies about 2,300 light-years away, a stunning farewell performance from a star in its final act. Through our most powerful telescopes, it does not appear as a chaotic cloud, but as a breathtakingly symmetrical structure, a glowing X shape contained within what looks like a rectangular frame. The geometry is so sharp, so precise, that it feels less like a stellar explosion and more like an architectural blueprint. The central star, a binary system, is the artist behind this masterpiece. As it sheds its outer layers, it does not do so in a random sphere. Instead, scientists believe dense disks of dust and gas around the star funnel the ejected material into two opposing conical outflows, like two giant ice cream cones placed tip to tip. From our vantage point, looking almost directly at the side of this double cone, we see the intersecting lines that create the iconic X, with the edges of the cones forming the apparent rectangle. It is a natural phenomenon, a consequence of physics and perspective, yet the result is a form of such startling regularity it appears crafted. The precise mechanisms that maintain this perfect symmetry over vast distances are still not completely understood, a reminder that even known processes can produce outcomes that feel impossibly designed. The Red Rectangle stands as a sublime example of nature's hidden artistry, a celestial structure that blurs the line between a random cosmic event and a deliberate construction. It demonstrates that the universe has its own sense of geometry, a native language of shapes that can mirror our own ideas of order and design. This natural perfection sets the stage for our final anomaly, a mystery rooted not in grand visuals, but in the silent, chilling perfection of mathematics. Even a dead star can host a final, perplexing mystery. Our journey ends with a white dwarf, the Earth-sized ember left after a sun-like star has died. Astronomers observed one such stellar corpse, and its light began to flicker in a strange, unpredictable way. A 2022 study proposed a natural culprit, a disintegrating planetesimal. This would be a massive asteroid or a minor planet, torn apart by the white dwarf's fierce gravity, creating a cloud of debris that periodically blocks the star's light. It is a compelling and likely explanation, yet the data left a sliver of room for something more. The irregular dimming patterns also fit, however remotely, the profile of a megastructure in a different context. Imagine a civilization that evolved around a star now reaching its end. Faced with a dying sun, such a species might embark on its ultimate engineering project, constructing a swarm of collectors to harness the last energies of their white dwarf, a final act of cosmic preservation before the long cold sets in. This idea transforms a stellar graveyard into a potential site for the grandest of constructions. Each of the 21 structures we have explored, from the great walls that bend cosmology to the faint radio circles and runaway stars, serves as a boundary marker for human knowledge. Some, like Saturn's hexagon, have been beautifully explained by natural physics. Others, like the wow signal or the dark flow, remain stubbornly enigmatic. But every single one, whether solved or not, has served the same vital purpose: to push the edges of our curiosity and sharpen the tools of our scientific inquiry. They remind us that the universe is under no obligation to be simple or to conform to our expectations. It is a place of infinite variety, where the line between the natural and the artificial can be breathtakingly thin. Having charted this map of cosmic anomalies, we are left with a profound question about our own place in the grand scheme. What does it mean to be a species that can look into the void and not only see these puzzles, but feel compelled to solve them? Yet the universe remains profoundly silent. All these colossal structures and fleeting signals exist against a backdrop of what seems like an empty cosmos, a puzzle known as the Fermi paradox. If the universe is so vast and so old, teeming with billions of planets that could support life, then where is everybody? The sheer number of potential civilizations should mean the galaxy is buzzing with activity, yet we hear nothing but a deafening quiet. This great silence is one of the most unsettling mysteries in all of science. The very anomalies we have explored could be clues to resolving this paradox. Perhaps advanced civilizations are not broadcasting radio signals, but are instead transforming their environments in ways we are only beginning to recognize. A Dyson sphere, a Bracewell probe, even a star used for propulsion, these are not communication attempts. They are simply the byproducts of existence for a species that has moved beyond the need to talk. Their signatures are not deliberate messages, but the inevitable infrared glow of their industry or the subtle gravitational tug of their engineering. We might be surrounded by cosmic neighbors, but we are listening for a whisper in a hurricane, looking for a specific grain of sand on an endless beach. This idea connects directly to concepts like the zoo hypothesis, which suggests that advanced beings are aware of us but have chosen to observe from a distance, allowing humanity to develop naturally without interference. In this scenario, the silence is not an absence but a policy. Our solar system could be a designated wilderness area in a populated galactic park, with all the real activity happening quietly in the background. Alternatively, the answer could be far more lonely. Perhaps the great filters of evolution, the steps from simple life to intelligence and then to a spacefaring civilization, are almost impossible to overcome. Maybe every civilization eventually faces a self-made catastrophe or encounters a natural cosmic event that wipes them out before they can leave a lasting mark. In that case, the silence is real, and we are the lone anomaly, the first and only voices in a cosmos that is otherwise empty. The search for these impossible structures is our way of probing these profound possibilities. Every time we point a telescope at a star with a strange light curve, or map a faint radio circle, we are testing the hypothesis that the universe is not empty but filled with builders. We are searching for the artifacts, not the artists, because the artists may be long gone, or they may be so different from us that their presence is written not in language, but in the altered architecture of reality itself. This grand investigation reframes the entire question. We are no longer just asking if we are alone. We are asking what a civilization becomes when it reaches the end of its technological journey. Does it vanish into virtual worlds, dissolve into a cosmic mind, or reshape the very stars themselves, leaving behind silent monuments as the only evidence it was ever there? The silence is not a wall, but a mirror, reflecting our own hopes, our fears, and our deepest questions about our own future among the stars. These 21 cosmic puzzles reveal a universe far stranger and more wonderful than we ever imagined. Each one, from the silent perfection of Saturn's hexagon to the ghostly imprint of the CMB cold spot, began as a crack in the foundation of our understanding. Some of these cracks have been sealed with the mortar of natural explanation, while others remain open, inviting the winds of new ideas. This is the true purpose of a cosmic mystery. It is not merely a question to be answered, but a catalyst that propels us forward. Our search for meaning among the stars is a fundamental part of what makes us human. We are the species that looks at a flickering dot of light and dares to ask if someone else is looking back, that maps the faintest whispers of radio waves and imagines the civilizations that might have sent them. The ultimate lesson from these anomalies is not about finding alien architects or rewriting physics, though those possibilities remain thrilling. It is about our own capacity for wonder. Every time we solve one puzzle, two more seem to emerge from the darkness, ensuring that the universe will never feel small or fully known. This endless frontier of questions is our greatest inheritance. If these journeys into the unknown have sparked your curiosity, we would love to hear which mystery captivated you the most. Share your thoughts in the comments and join us as we continue to explore the deepest enigmas of the cosmos.